So now we're going to look at the chemistry of the group 2 hydroxides. So remember that we're in group 2, so our metals have a 2 plus charge, and hydroxide is a 1 minus ion. So we're looking at the formula M brackets OH twice. So the group 2 hydroxides are bases. That means that they are proton acceptors, H plus acceptors. And they're going to react with acids, H plus donors, and they're going to form salts and water. So let's just do an example with M to represent our group 2 metal, which means that we can replace it with any letter of any elements from group 2. If we were to say react with hydrochloric acid produces chlorides for the salt, so we'd get MCl2, and then we'd get water, and we would balance that equation like this and this. What if we took them and reacted them with sulfuric acid? Then we would get the metal sulfates, and group 2 sulfates have the formula MSO4, like MgSO4, and then we would get 2 waters as well. And you could choose other acids, like nitric acid would be very similar to hydrochloric. So if we were to do M brackets OH twice, and we had nitric acid, because that's monoprotic, has 1 proton, just the same as hydrochloric, it would be very similar, but because the nitrate ion is a compound ion, we'd have to have 2 of those. We would have a brackets, but other than that, our equations are identical. Okay, so they all react with acids, and you've got to be able to write any equation of any of the group 2 hydroxides, so calcium hydroxide, for example, with any of the acids, or magnesium hydroxide with any of the acids. So what about the chemistry of the hydroxides? Let's write down their formulas. So if we swap the M for Mg, or the M for Ca, or the M for Sr, or Ba. Now, if we recall from our previous learning on their solubility, we know that magnesium hydroxide is sparingly soluble. That means really not soluble at all, and a white precipitate would form if we reacted magnesium with water. All the way down to barium hydroxide, which is fully soluble. So our solubility is increasing as we go down. And as more and more of our hydroxide dissolves, more OH minus ions are present in solution. So we go from being barely alkaline to being very alkaline. So our pH increases as our solubility increases. So if we had to predict calcium, maybe we'd go 10 and then maybe 11 or 12 for strontium. So the solubility in water increases down the group, and the pH increases down the group as more OH minus in solution. The more soluble it is, the more of the hydroxide ions are in the solution. What about some uses of our group 2 hydroxide? So we've got magnesium hydroxide in medicine. So magnesium hydroxide is used in indigestion tablets like Rene's, milk of magnesia, those kind of indigestion remedies, used in indigestion tablets to neutralize excess stomach acid. So it reacts with the stomach acid and neutralizes it. Then we use calcium hydroxide in agriculture, in farming, because calcium hydroxide neutralizes acidic soil.